Fami MFA and my IT number is IT21037306. I have contributed to this project by fixing some vulnerabilities and implementing OAuth 2.0. The first vulnerability that I have been fixed is from frontend, which is caused by old Axios version. So I have just fixed it by upgrading the Axios to the latest version. So the next vulnerability that I have been fixed is this issue 5, which is a medium risk vulnerability and which is caused by the React script version 5.0.1. So I have fixed this vulnerability by just adding another dependency called post CSS. So the next vulnerability that I have been fixed is from backend, which is caused by Cloudinary dependency. So I have just fixed by upgrading the Cloudinary to the latest version. So the next issue that I have been fixed was the issue 4, which is caused by the JSON Web Token version 9.0.0. So I can able to fix that by upgrading JSON Web Token to the latest one, which is version 9.0.2. So the next issue that I have been fixed was this issue, which was a high risk vulnerability. So I can able to fix this issue by just move all the credentials of Cloudinary config to the .env file. So the next issue was caused by the regis expression. So I can able to fix those issues just by sanitizing those input before going to the processing. So which is called sanitization. So I just sanitize the input before it going to the process. So the next issue that I have been fixed is this one. So which is caused in the Express app because we have to disable the XPower by header. This is a vulnerability. So I can able to fix that issue by just adding another line to the code. So these are the contribution that I can made by fixing vulnerability. And the next contribution is the OAuth implementation. So I implement the OAuth 2.0. This is the OAuth 2.0 backend implementation. So this is the actual code. So I have used Passport library in order to implement the OAuth 2.0 in this application. So I have initialized the Passport library and I have created a passport that session of that library. So I have used Google strategy, which means I created the OAuth 2.0 by Google Auth. So these are the codes of implementing the OAuth 2.0. This is the backend code. So this is my contribution. Thank you.
Hi, my name is Lochini Javardhana, and let me walk you through the vulnerabilities I have found in our application and the approach I took to mitigate them. So first, in front end, I have used black box testing technique, and by that I have identified the vulnerability cross-site scripting. In order to fix this error, first we should check for multiple versions of dependency by npm ls serialize javascript command, and then by running the npm dedupe command we can resolve the supplicated dependencies. And we should check for both transitive and dependencies and override specific packages. So if a specific package is causing the issues, we need to override that package. So below is an example. I have override the React script in our application to avoid such issue. And next, let's focus on the backend. And again, using the black box testing technique, I have identified some issue. So this is an server-side request forgery. So this vulnerability was introduced through the Mongoose 6.9.0 package. So to address this, the dependency was upgraded to the latest version. Then that has resolved the problem. So these are the screenshots to prove that I have fixed the issue. And next, by focusing on white box testing technique, I have identified some vulnerabilities there too. So this is a medium risk vulnerability, which is information exposure. So the problem here is sending an entire object, and this could disclose sensitive information about the internal workings of the application to an attacker. So by sending a simple or error message, we can prevent exposure of sensitive information and enhance the security of our application. And this is a proof that I have used in our application as well. So, and another vulnerability I have found is a sensitive cookie in HTTPS session without secure attribute. So to address this issue, I have enabled HTTPS session cookie for OAuth, which is the correct approach. While OAuth can support both HTTP and HTTPS, using HTTPS is recommended for secure communication. And this is the proof that I have configured that in the middleware of our application. And that's all. Thank you for listening.
Hello, everyone. So this is a front-end vulnerability with high risk, that is regular expression denial of service. So in order to fix this issue, first we have checked the multiple versions of the dependency by running this command npm ls and check. And next by running the npm dupode command, we can remove the duplicated dependencies, and at last we should check the transitive dependencies and override specific packages. And when overriding the packages, if some packages is if a specific package is causing some issues, we might need to override that package like this. So doing those things, we have fixed this issue. And the next one is this vulnerability is with medium risk, which is missing release of resource after effective lifetime. This was caused by Pinopretty 9.1.1. To overcome this, we have upgraded the Pinopretty package to this. And the next one. So third issue, this is also a vulnerability with medium risk, which is a cross-site script request forgery. To address this vulnerability, CSRF protection was implemented using the CSRF dependency like this. Like this. So this measure helps to prevent cross-site request forgery attacks by ensuring that requests are accompanied by a valid CSRF token. So by this, we can improve the security of the application. And the last one is the issue with the low risk, which indicate improper type validation. So to fix this issue, the mentioned method was validated to ensure that it is a string. So here I have validated that. Here that is validated. So this will prevent the potential security issues by ensuring that only the accepted data type is processed. So that's all. Thank you.
Hello everyone, my name is Sanjeevan. So for this project, as part of my contribution, I focused on both the front end and back end of our project, conducting through black box and white box testing to resolve critical issues. So starting with the front end in black box testing, I fixed issue 4, a medium risk vulnerability. So this was resolved by adding the minimalist dependency to fix this issue. So this minimalist dependency, which helped to eliminate duplicate dependencies and override specific packages. This improvement strengthened the front end by ensuring better security and smoother operation. And next, I did the white box testing and it only had the one issue. So I tackled issue one. This involved ensuring that URLs submitted by users were first validated to confirm they were legitimate and then sanitized to remove any harmful content. So this step was critical in preventing potential attacks like cross-site scripting, thus improving the security of our application. And then I come to the backend. For the backend, I also participate in both black box and white box testing. In black box testing, I addressed for issue 3, a high risk vulnerability test that was introduced through the Express package. The solution was to upgrade the Express dependency to the latest version, which resolved the vulnerability and ensured that the backend is protected against known exploits. And finally, for the white box testing, I focused on issue 3. It's also a high risk vulnerability by modifying the backend to enhance how user data is handled during login. So, like previously, sensitive information such as passwords was included in the user object returned after login. So, I changed this so that only necessary details are shared, ensuring that sensitive information remains protected, significantly improving the overall security at the backend. So, in conclusion, my work on both our front end and back end ensured that we were able to address several key vulnerabilities and contributing to the robustness and security of the system. Thank you.